go through this exercise. It's number 13 in section 5.5. It says the radio tower is located 400 feet from a building. From a window in the building, a person determines that the angle of elevation to the top of the tower is 36 degrees and that the angle of depression to the bottom of the tower is 23 degrees. How tall is the tower? All right, so first let's make a quick drawing. All right, so let's draw our building. Here's our building right here. Here's a window. So somewhere in the building, there's someone in that window right there. And then there's a tower over here. I'll just draw a line for the tower. Now, there's a couple of things we have to assume. First is we have to assume that the ground is flat. And then it's 400 feet from the building to the base of the tower. And the second thing we have to assume is that the building is straight up and down, so we have a 90-degree angle. It's not like the Leaning Tower of Pisa. So those are reasonable assumptions to make. So now the person is looking out the window, so let's draw a line. That's the horizontal right there. And so if the person just looks directly out of the window horizontally, he or she will see that point of the building. But it says here that the angle of elevation to the top of the tower is 36 degrees. And so that means angle of elevation means from the person, the angle from the horizontal up to the top of the tower, that's 36 degrees. Okay, that's anytime you have an angle of elevation, that's called 36 degrees. Now it says the angle of depression to the bottom of the tower is 23 degrees. So that means that the angle of this line right there is 23 degrees. Angle of depression means the angle from the horizontal to the line of sight down to the bottom of the tower. Okay, now from geometry, you have parallel lines. We have a horizontal line here. We have the ground. And so if this angle of depression is 23 degrees, then this angle also has to be 23 degrees right there. That'll be a little bit easier to figure out that angle right there. And same thing up here, although that's not going to help us, but that angle up there would be 36 degrees as well. All right. So now let's label some variables. And so we have this. Let's switch to a different color here. So this part of the tower, the length of that part, let's just call that A. And then the length of this part, we'll call that B. You can use whatever letter you want. Doesn't really matter. Okay, so from here, it's just a matter of using trigonometry. We have two triangles. And so you just have to use the correct ratio. So we have, let's start with this. And by the way, this is also A. So that the height from the ground to the window, that is A. That's the same as this A over there. So you can use that side if you want instead. In fact, I think I will. It just seems a little easier. So we have, here's our angle right there. So side A is the opposite side, and this 400 is the adjacent side. So we have opposites over adjacent. That means tangent, right? Remember SOHCAHTOA. And so we have tangent is opposite over adjacent. So that tells us the tangent of 23 degrees is equal to A over 400. Okay, so once again, that's tangent of 23 degrees equals the opposite side, A, divided by the adjacent side. Okay, and then we can solve for A. But let's not do that quite yet. Let's figure out the other angle here. So we also have angle B. And so, not angle, side B. And so this distance right there, this is also for this triangle, the base of that triangle is also 400 right there. So we can also say that tangent of 36 degrees equals opposite, which is B, over adjacent again. So tangent of 36 degrees is opposite, which is B, divided by tangent, which is, adjacent, which is 400. Okay, and then I can solve for B pretty easily. And then once I know A and B, add them together, and I've got the height of the tower. All Okay, so let's take this 400 and move it over to the other side. So 400 times tangent, tangent of 23 degrees, whatever that is, that's equal to A. Now, just get out your calculator at this point. Do 23 degrees, take tangent of it, get whatever you get, and then times by 400. Use whatever calculator you want. So I'll just use this calculator that comes with Windows here. So if you click, you go to menu here and click scientific, and then you have trigonometry right there. And so let's type in 23 degrees, and the default is degrees. It says degrees right there. 23, called trigonometry, tangent. Okay, tangent of 23 degrees is 0.424. Times that by 400. And you get about 169.7899. Rounded off, 169 points. What was that again? I'll do 7899. Okay, now in real life, it's kind of silly to have that degree of precision, because there's going to be more error in measurements in your measuring of your angle and the measure of these 400. So it looks like really just two significant digits, but oh well, I'll just keep all the numbers in there. I'll just presume it's exactly 23 degrees and exactly 400. Okay, now that's A. Okay, B, solve for B. So so move the 400 to the other side. I have 400 times tangent 36 equals to B. And back to the calculator, press clear. So 36 degrees, tangent is 0.7265. Times that by 400, and I get 290.6170. 290.6170, I believe it was. Okay, that's B. Okay, so I figured out, I'm almost done. So the height, this part A is about 169 feet. B is about 290 feet. Add them together, and I've got the height of the tower. Okay, so one more time, back to the calculator. So 169.7899 plus 290.6170. Okay, so answer 400. So let's go back here. So the height of my tower, 460.4069 feet. Okay. However, like I mentioned, your answer shouldn't really be any more precise than the original measurements. And so this measurement is 2 degrees of significance. The 400, well, I suppose you could say 400.0, maybe 3 or 4 digits. And so really, it would be best to round this off to say 2 significant digits. So 460 feet would be a more reasonable answer for this. All right, that is it.